Hello guys, so I want you to try something. I want you to head on to Google and type CK12 simulations and then click on it. And then you will get onto this website CK12. It's a non-profit, so we might learn a little bit about it later, but like then you head on here. So CK12, it's an American website, I guess. So we have, it's available in various languages: Korean, German, Chinese, Greek, Polish. So we'll stay with English. Now we have simulations. So here you can run like literal experiments of physics and chemistry here without using the lab. So everything would be based. So I recently, so let's try the chemical simulation. Let's try this airbag one. So this is based on stoichiometry and how this works. So the question here is, how does a chemical reaction inflate an airbag? So as we know that in cars we have airbags that inflate so that the injury could be minimized and the person's life could be saved. So let's begin the simulation. So what
To protect drivers on the road, most modern cars have airbags.
Look at the test dummy here.
In a crash, a sensor detects a sudden change in a car's speed. It creates an electric current that triggers a heat source in the airbag canister. The heat causes the chemicals in the airbag to react, inflating the airbag. This whole process has to happen really fast, within about 30 milliseconds, in order to cushion the passengers in the car against impact. Can you make a chemical reaction that will inflate the airbag in time to protect your crash dummy?
Yeah, so let us try this, okay? So now we can head on to the simulation. So first they explain the concept and how, and concept and then its application, that why the rate of a reaction might matter, because like that it might be needed in very rapidly, for example in this case. So now we'll head on to the simulation. So in simulation we have three things. We have a graph, the chemicals that we'll use and the amount that we'll use, and here the chemical equation will be given. So we'll go to the settings and learn about what this graph is showing. So I know, but like we can, this is just to show the features of the graph. So volume of the gas with time would be shown here. And then what other thing that you could find on this is, oh god, zoom. You can zoom in. So basically this graph would appear on a much larger scale. However, the simulation won't run. Then you can hide graph as well. Enable raster run option is so that you can compare the two graphs that will be plotted here. And then we have sodium azide, ammonium nitrate and nitroglycerin, and we might learn about here these as well here. So these are the chemical that will be used here in the canister. So what is the composition? If you're not sure what a azide is, if you're not a JE student, or what this is, nitroglycerin is, no problem, because they have given this here as well. You can click here and get what is a molecular explorer this. So azide actually is N3 minus and sodium is Na. They both come together to form this. So here what you will see is this purple one is this and nitrogen is this, and you can see the difference in size as well. Now so now here is some information that this is an ionic compound and where is it is used and stuff like that, and a few important equation that you can go through. And apart from that, like we can look up other as well, other compounds as well, that is ammonium nitrate here. And you could look at, like, the scale is very nice, that is you would be able to compare that the hydrogen is like small and oxygen is bigger, and how they are connected, sort of like these models. And again, some information that you can go through. And nitroglycerin, look at this compound, so beautiful, and they like rotate all as well, so that like it from all the sides, the configuration. Because if when you learn optical chemistry and all, like you will get to know that this has major significance. Yeah, so okay, now we will just go. Now amount of chemical, they have taken 1 mole only. So now this is the amount of chemical they've used. So I don't know, but I think this slider doesn't work, because when I try to drag it, it goes back to its old amount. So now let us try it. Okay, so we will take sodium azide first and in this, and then run it. So you can click on this play pause button and run it. So this inflates, and this is a graph. Okay, so the person is saved because this was able to happen. Okay, now what we do is, okay, so we are gonna, no, show current. Okay, so now we're gonna use nitroglycerin. So I know what's gonna be the result. Okay, this bag is just gonna inflate and the dummy is gonna die. So like, let's begin. Okay, this is the previous one, a sodium azide, and this is the current one. So let's begin. Okay, oh, look at this. So our dummy died. Now we can try the ammonium nitrate one. So now this one will stay. That matlab this one will stay, and now we'll be comparing it with this, will become our current simulation. So now we might run it, and mind you, like, there are equations also going on here, so you may give emphasis on that as well. So now here the maximum air volume is used. So if suppose there is a company like Tesla, or like there are a lot of car companies, they want to go for it, they will obviously go for the best option that will be best for their customers. And so, and like, the volume should be maximum to minimize the injury. And so here you can say what is the most optimized solution here. This is ammonium nitrate, and here you can look for formulas as well. I hope this video helps you to understand. You can explore other simulations as well. These simulations are really great to ignite your interest in the subject and also make it more practical. So there are more segment, I guess. So let's move on there. So real world examples. Okay, so like in the same thing, we have more as well. So you can explain. I think this is from the chemical reaction itself. So related. So can you split apart water? This is part of electrolysis. Grape juice, this is related to fermentation and all. Why do sodas lose their frizz over time? So CO2 and all. So they'll give you a very brief concept, so it won't be very theoretical. It would be just enough to make you understand. Okay, so suppose this is a Coke or any carbonated drink. So then can you split apart water? So yeah, electrolysis again. And like in yeah, so how does it split, and like what will be the volume and all. And this is going to be anode, cathode, electrolytes. They have used this to signify that graphite is also used in pencils. And like, if you, I don't know, maybe graphite is expensive or something, so they have used this. Yeah, what turns grape juice into wine? Fermentation reaction. So this is also one of the examples. So yeah, that was it. Thank you.